So, a couple of quick housekeeping things before I get started. First, I want to apologize for ending the last video very abruptly. It was because I had filmed a bunch that I expected to be in that episode, and I realized it was dragging on too much. So I ended part one, even though I had some more footage after it, which is going to be in this video. Second thing is, my normally really high fashion standards are very low because I'm recording this between coats of paint, and I don't feel like switching into presentable clothing back into my painting clothing. Yeah. Third thing, I can't believe you're all out there. Thank you. Honestly, like, wow. Pretty awesome, eh, Tatters? Somebody find our little project interesting? Damn. Y'all are amazing. Really. 5,000. Thank you. I genuinely can't, thank you. I can't believe there's so many people who are interested in this weird little project. Right, let's back to it. Hello, got the spreadsheet ready, but before I get into that, I can't get yet how much power this needs. I know I need a buck converter to step down from 48 volts nominal to 24 volts, but apparently my reseller keeps asking JK, and they just say, you need a buck converter. It's like, well, yes, but how many amps? How many watts? So I'm gonna try to figure it out for myself. So I've broken out the iCharger again. Well, let me bring you in, I'll show you what I'm doing. All right. So what I've got is the negative going to the yellow. I don't even know for sure that that's ground. Actually, I can see in there it says ground. You know what? I'm just going to take this apart. Maybe I can find some information on the silk screen. Where's my screwdriver? I think this will work. Yep, this will work. I've asked for the spec sheet for this and I haven't gotten it. So yeah, I'm operating under the assumption that I'm on my own to figure this out. Oh, there's a little speaker beeper back there. There's a couple of ribbon cables. I wonder if one of these are standard VGA. Ooh, actually, do I have the part number? I see a silk screen, but I can't really read it because eyes. Beta 043 Sierra X-ray 4 Victor 10. Let's see if that is something useful. V10. Please. Absolutely nothing. Damn it. The fallback is, I'm hoping this will tell me how many amps it's drawing when I set it to a particular voltage. So I'm going to set, this is already set to 25 volts. I'm going to set the iCharger to 24 volts and see if this thing fires up. Now, that'll tell me the amp draw as it fires up. It's not going to tell me the amp draw under highest load, but I can add 10 or 15% to the number. I mean, it's better than what I've got to work with right now. What I've done is I just stripped a little bit of the two wires and use the bolts to stick them together. It is hacky, I know, but it should do the job. This iCharger is becoming more and more awesome every day. 1 amp should be way more than enough. You know what? I'm going to set it to 12 volt to undervolt it because I'd rather provide too little power than too much. And get you viewing in on the screen as well, so that if I blow up the screen, at least it's good YouTube. That's still connected. I'm going to put that over there as a way to isolate those because that's totally OSHA approved. Let's turn on the breaker and see what happens. All right. It's G-Kong, it booted up, and I've hit, I think I saw 0.15 amp. It's showing 0 everything. This is actually a really nice screen. And it's touch, ooh. Ooh. This is nice. You know what, let's turn this off and back on again. Highest, 0.4, 0.5, 6, 7, 8, 9, 12, 15, 16, 15, 14. 1.6 watts. So I think I'm going to say 2 watts. I don't really want to buy a buck converter for every one, but that would be the right way to do it. Why don't you support 48 volts? Oh, that screen does look nice. Oh, wow. G-Kong, JKBMSs are a goddamn enigma. I love them and I hate them in equal measure. That is a really clean screen. They just do nothing to help the end user. Well, anyways, now I know what size buck converter I need. I can set this aside and start sorting this out. The next step is to start recording the internal resistance and scanning the QR codes and recording it in the spreadsheet. And for reference, I'm measuring at the base of the threaded rod, 0.16. And what's the rated they came at? They're rated at 0.21, but again, I don't know the state of charge. Holy shit, that's a huge difference. This is floating all over the place. Okay, it's stable at 0.20, so why is this one so low? Okay, instead of doing the base of the threaded rod, I'm doing the edge of the, I guess it would be the bolt head before it was welded on. Here I'm seeing 0.21, which is closer to what the sticker said. So you know what, I'm gonna undo my first reading. I'm gonna think that's anomalous. I'm gonna call that 0.21, and I'm gonna call this one, why are these all over the place? Now it's saying 0.18. It was showing 0.24 earlier. 0.18, 0.21. Oh, okay, this is gonna be fun. It's going to be like that, is it? 0.21. Come on, unhook thyself. 0.22 now, it was 0.18 before. What the actual fuck? I don't have a lot of confidence in the accuracy of this internal resistance reading. It's all over the map. Every time I read it, it's coming out different. 0.21, now it's 0.17. These internal resistance readings are all over the map. 0.16. What the hell am I making of this? I don't know what I'm making of this. I'm reading it again. 0.17. Is it piercing the aluminum oxide? Yeah, now I'm getting 0.17 up here. What I'm doing is I'm kind of intentionally digging. Yeah, I got 0.17 across all of them now. I don't know what to make of this. I don't know what to make of this. They're all just read 0.17. The readings are all over the map. Well, I'll keep going. I'm going to try this time. Very light touch on the edge, just barely compressing the spring pins. And I'm seeing 0.24. Now I press hard, rubbing back and forth a little bit on each of them to get through the aluminum oxide layer. And it's still showing 0.23, 0.24. What the absolute bloody hell is going on here? Okay, no matter what I do with this one, it seems to be staying at 0.23. What if I do the top of the post? 0.8! Holy shit! What if I do the edge of the underlying terminal? 0.23, which is consistent. Okay, so these are probably steel, which should explain it. I am rapidly losing trust in the idea that the internal resistance of the cells is useful. It is so all over the place, and none of them are close to what the sticker says. What am I doing this for? Why am I spending time doing this? I think I'm wasting my time. There's no sense putting a couple of hours into collecting this data if the data is random from one probe to the next. Oh, that's annoying. Okay, let's try a QR code on A04. Okay. Are you going to scan? Scan aborted, no data available. It's not scanning. It's got a good picture on the QR, but it's not actually deciphering it. This is using the LifePo QR battery QR scanner. Yep, not entering it. Okay, there's a enter manually. 0, 4. Wow, I'm really striking out today. QC. Content is not valid. It should be 19 or 24 characters long. Oh, okay, so the first number is part 1. The second number, starting with C in my case, is apparently part 2. Haha! Finally got something. All right. February 25th, 2022. These are new cells. Okay. I will put on the screen a picture of the QR code I just manually typed in. I don't know why the app didn't scan it, but the QR code is valid. And yeah, February 25th, 2022. Without an app, I'm not doing all of these by hand. That would literally take all day. So for now, considering they were all ordered at the same time, I'm going to assume these are in fact really new cells because I placed the order not long after April. So they would have been like 2 months old when they shipped out. So that's really good. I'll keep trying to find a way to QR scan these. Finally, holy shit, that took a long time. I wonder if I add some extra light, if that'll help. That helped. That was a lot faster. Wow, okay, yeah, having an extra light, that makes a big difference. I will say, Amy at QSO has been very good about helping me out. Jeez, I think a sticker popped when I leaned on it. It scared me. That is February 7th. What is making that noise? Jingmen City, production line 83, factory task order 73, number of cells produced 6,299. That's really kind of cool. Oh, let me try that again. It doesn't recognize that. It says unknown everything. Yeah, just needed to rescan it. February 5th, February 23rd. I really don't know how useful this data is going to be. Why am I putting my time into this? They're all coming back consistently made in February. You know what? I might finish this later, but I'm not doing it now. I don't see the value in the time it's taking. I'm going back to putting crimps on that like I said I was going to. Just checked the GoFundMe I was talking about last night, and Brupeg's already got enough for a brand new engine and probably enough for a generator as well. Did I mention I love the internet? I love you guys. The fifth pack, battery E, BMS E, is terminated. So I've got one left to go. One BMS actually totally completely done. Well, plus whatever I have to do for the panels, but you know what I mean. That BMS is done. Now I need to do 5 more. And these do not want to go in cleanly. There's so many tiny, tiny little fibers. They don't really hold their shape. Oh, twisting it while I put the lug on actually made it a lot easier to keep them straight. Huh, there you go, okay. Done. That wasn't a lot of visual progress, but that was a fair bit of work. Not complaining, just stating. So now that all those are cabled up, oh, you see the little jump I just did there? I have a couple more things I want to cover. One, I've got the parts. A few people were saying, well, why don't you just get a buck converter to drop the voltage? It's exactly what I've done, and I've got the parts here. Thanks to a friend of mine. He gave me a couple of parts that I should buy and how to assemble them, and that's what I'm going to do. And that should let me power these up directly off the batteries. So I'm going to work on that tonight and get those built up and test them. The other thing I did that I didn't film because it was mostly just woodworking and a lot of thinking, it's going to look very simple, but it took me a long time to figure out, is I needed to come up with, I mentioned in the last video about how I need to make a cover for this. And every time I thought about how to do that, it was always going to be fairly involved, which if it was going to be a long-term solution, I have no problem doing an involved job. So what I've decided to do is I'm just going to cut a sheet of that door skin, that oak door skin that I've got, that's going to cover these cells and have a lip that drops down to cover the BMSs once the batteries are assembled. And I've made this little stand, which has legs so that it doesn't tip forward when I start hanging cables off of it. The input is on pin 1, bottom left. Output is pin 3, bottom right. And I've got 2 capacitors. The blue stripe is apparently the negative. So I'm going to take the 2 negatives and tie them into, I doubt you can see a thing here, but into the center pin. And the 2 positives will lead to the out to 12 volt and the in from 18 volt. The in from 48 volt. This is not going to be pretty, and I don't particularly care if it's not pretty. I just need this to work. I don't know if this can be seen, but the 2 negative terminals of the 2 capacitors are in line with the center pin on the buck converter. Let's run the soldering station from the batteries. Actually, I'm curious what kind of load this puts on it. It started off at like 180 watts, but it's already down to 53 watts. This is not taking very much. All right, it's been a while since I've done any soldering. And I'm not a very good solderer in the first place, so anybody who actually knows what they're doing, you might want to look away because this is probably going to be pretty cringe. I should probably be soldering this from the other side, except I can't. Maybe I need to put these all in backwards, which means I gotta straighten this all this out. Oh, I'm not very good at this, but that's okay. So what I'm doing is the solder pads are on this side. I was trying to solder from the back side, which is completely really backwards once you think about it. I don't know if you can actually see on camera. Can you see that? These little circuit boards have, it's kind of like a tiny little mini breadboard for anyone who's ever used one of those. Anytime you should like to melt, please. Okay, it's still blinking, which tells me it's still heating up. There we go. Oh, this is terrible. I'm really not good at this. Also, this is lead-free solder, which is a bit harder to do. Oh my gosh, this is shameful. Oh well, I can only do my best. So the buck converter is soldered on now. One of those magic hands would be really nice right now. Hold what you're working on. See, that one went really well. That one just flowed right onto the pad. What did I do differently that time? Keep practicing, get better. I don't know what I'm doing differently, but suddenly it's going better. I think I have a bridge. Where's my multimeter? No, I don't. Okay, that's good. All right, so my components are soldered in. And the reason I'm doing this instead of just buying a pre-made one is that none of the pre-made ones I found were even close to the low amperage I needed. They were way overpowered and thusly very expensive. Oh, hi, Tatters. Ooh, buddy. A cat and a hot soldering iron. What could possibly go wrong? So, oh, you gonna go now? All right, he's gonna go. So I wanna go, actually I need 2 negatives. I closed up that hole. I need to open it up. I used to have a solder sucker. Oh my gosh, I actually have it right here. What are the chances? Like seriously, I did not stage that. I don't know why that's here, but I'll take it. Did that open it up? Kind of. Solder sucker literally just creates a vacuum and sucks the melted solder up into it. And if anyone gives me a hard time for saying solder with an L, I shall tell you to kindly go away, because that's how it has an L in the name. Get both of these in right away so that I can just solder them all at the same time. I am comically bad at this. That looks a lot better. So what I've got now is the center pin of the buck converter, pin 2, is now connected to these 2 wires. I'm going to run each one to the ground of the capacitor. So the blue is the ground, and the blue is the inside pin. Where I have the 2 capacitors coming through, I'm going to run the ground over to them. All right, that's connected. Oh, balls, that's what I didn't want to have happen. I just pulled all the insulation off. Actually, what I can do, I will try cutting it right here and then seeing if I can jam it back in. I'm basically shoving the insulation back onto the wire. Oh my God, it worked. Oh, this is so terrible. Oh my God. All right, whatever. If it works, it ain't stupid. Why didn't I just spend the extra money and get finished ones? I know why. It'd be boring that way. As shitty as this might be, at least I'm learning. The key thing is that I've got the insulation crossing the positive lines coming off of the buck converter. I don't want those touching ground. That's a dead short. Okay. So before I do anything else, I want to make sure I didn't create any shorts. I should have a short between ground and here. I do. Okay, so the grounds to the 2 capacitors are good. No short. Now I'm checking the positive pins of the capacitors. No short. I'm checking across pin 1 and pin 3. No short. Okay, the ground pin coming off of the buck converter is going now to the ground pin of the 2 capacitors, and there's no shorts between the grounds and the positive of either capacitor or of pin 1 or pin 3 of the buck converter. So far, so good. So now I got to do the positives. In this configuration, this side is the input, that side is the output. So this is going to go to my 48 volt, which is going to go to the battery, and this is going to go to the screen. And this is just flopping in the breeze. I don't like that. I got an idea. I'm going to try creating a little strap to hold this in place. And I just burned my finger. I just burned my finger nicely. Wow. That turned that skin white very, very quickly. Okay, well, anyways. Sometimes it feels like it just flows nicely, and other times it feels like no matter what I do, I can't get it to flow properly. Wow, that's a bad burn. I should probably go address that. Yeah, that white spot. That's cooked Digimer. All right, one bandage later. See, that one just worked fine. What did I do differently that time? And now that side solder is flowing nicely. I don't know. What was the difference? You gotta suck at something before you can be sort of good at something. I'm going to include this, even if it makes the video terrible, if only to show that you gotta suck sometimes, and you can't just start out being good. It's just the way it is. Ain't that just A grade right there? None of this would be a problem if JK sold parts that were compatible. Not to excuse my own crappiness at this. Anybody who knows what they're doing, you're absolutely welcome to criticize me in the comment section. Criticism in the comment section boosts engagement, so I mean, hey, have at it. I just did a bunch of work and I forgot to turn on the camera. I finished soldering it up. Big if, I did it right. Purple and black should be 48 volt in, yellow and black should be 12 volt out. So my friend who was helping me design this, one of the things he was saying is to put a diode on this if I was going to do this properly, which I will later. If I connected this the wrong way, it would blow things up very quickly. So what I'm going to try doing, just to make sure I've got this working as a proof of concept, and I'm going to call it a night because it's pretty late. So I'm going to go get the iCharger. I'm going to try putting some voltage on the input and see if I get 12 volts on the out. All right, I'm going to give it 24 volts output. Can I reduce below 1 amp? No. Let me bring you in so you can see this jankiness in all its close-up glory. So right now I should have nothing, and indeed I have nothing. Fuck, I'm nervous. When I flip this breaker, that'll provide 24 volts to the input of the buck converter. Assuming nothing blows up in my face, which is entirely a possibility, so I'm going to actually look away when I flip this. If nothing blows up, I should measure 12 volts across here. Okay, nothing smoked. That's a good sign. I am getting 24 volts. So, do I get 12 volts? Holy shit, it works! Oh my god, it works! Holy shit. Okay, I gotta turn this off. It fucking works! Oh my god. It didn't blow up and it worked! Woo! Alright. I'm gonna turn that off. I am going to stop on a high note. Okay. I'm not quite sure why I've got such a shadow here. I think that's from the camera. Oh, that's better. Anyways, good night. Back. I think the recording I was making yesterday where I was making this was a little bit chaotic. It's been a crazy couple days. And this is going to be a crazy video, I think. I'm bouncing all over things, but hey, that's the nature of a project. So now that I know that the buck converter works that I'm going to make, I've put that project aside because I can't use the screens until I finish assembling the batteries, and that's what I need to get back to. But also, I've got some connectors and some protection diodes on order that should hopefully be here tomorrow. Well, bye. Anyways, before we get back to building the batteries, I got another toy. Let's open it up and see what it is. Right. This is the last part I needed to get the new LFP batteries working on the boat. This gives me a way to charge it. This is the quite new and a lot bigger than I expected. Oh my gosh. I thought this was going to be the size of... Oh, sorry, bye. I thought this was going to be the size of... So we're going to see how durable it is. I thought this was going to be the size of the MPPT controllers. Clearly it is much bigger. I cannot believe I just dropped that. It landed on the blue side, and I don't see any issue. And it is a Victron, so I expect it to be pretty durable. This is the new Phoenix Smart Charger IP43. I got the 12 volt, 30 amp, 1+1. They have a 50 amp version of this that I thought about getting, but because the 12 volt system is going to be used principally for, well, for now running an inverter, but I'm not too worried about that. With the LFP batteries, I'm gonna have a stupid amount of power. The idea behind this is that it is what I'm going to use principally to keep the 12 volt pack charged up. And if you recall, the 12 volt pack is going to be responsible for communications equipment, nav lights, and whatnot. More importantly, the reason why I've got this already, my boat as she sits with her diesel engine is a 12 volt boat. This I'm going to be taking with me down to the boat next time I go down, and I'll actually start swapping out the lead acids that are in there, which are close to the end of their life anyway, and I'll finally start the actual electrical conversion, if only the auxiliary systems for now. So I'm really quite stoked about this. I can't play with this until I get the 48 system built, 48 volt system built, because I need that online so that I can disassemble the old 48 volt, because that's what's currently powering everything here. So let's get back to it. Pretend this is the front of a full 16S battery. The plan now to get these wired up is I'm going to have, it'll come from there down to here, from here into the fuse, and then out of the fuse to the back terminal of the main switch. And then coming off of this, conveniently I have one left over from my previous experiment, it's going to come off of the main switch and go out to the Anderson connector. Then I need to do the negative side. So on the negative side, it would be nice if I could actually just do that. Then I wouldn't need to have a jumper here, and that would save me some terminals. Do I have enough space to do this? Could I wish these cables were a bit longer or didn't exist and just had a bolt pattern. See, what I'm trying to avoid doing is, if I do this, then I need to make jumpers to get me rest of the way to the main pack negative, which means I have resistance at this joint. I've got the cost of a bunch of little cables I need to make, yada, yada, yada. If I can mount this like this, run these up and out to all of the batteries, yeah, but see, then it's off to the side because this switch, unless I make the batteries deeper, if I bring the main switch out so that it clears that's how big the main switch is. You know what, if I do that, let this go behind, that's gonna save me a resistance point and cabling. You know, that might just be the way to do it. Let's go off like that. This would still need to have a connection to the wire that goes out to the Anderson connector, but at least then I'm only making one. I think this might work and use a lot less parts. Okay, I need to figure out the length to match this because I don't have a box to fix things nicely, so I'll figure that out. That's a solvable problem. Yes, that'll work. The other issue I have, it's not a huge issue, is if I use this heavy 4-gauge wire and I want to dive almost immediately into the fuse, this wire is really dense and hard to twist. It wants to flip back up. There's a nice short wire. It's really, really stiff and hard to get it to come around to where I want. So I have this. So I might do the same idea I did with the flexible bus bars, make them a little bit longer, and it makes it easier to drop it down like this. Oh, but I want the fuse further out now because the BMS is going to be here. So how long do I want this to be? So the BMS is going to be sitting back here now, right? I think so. For the length that goes from the bottom of the fuse into the back of the switch, that'll be rigid because it doesn't have to go over a tight bend. Likewise, I can use the 4-gauge coming out going to the Anderson connector. Yeah, that feels good. Let's do some more of these. Now, this is going to become my standard bearer, and I need 6 of these. So that means I need 24. I can do math, me. Take another one of my bad stickers, just to mark this as my standard wire. Oh, see? That is exactly why I put the tape on it. I almost used my cut piece. You know what? I think I'm going to make 2 more of these for the 12-volt pack. I don't know if the 12-volt pack is going to be laid out the same way, but even if I put the BMS on top, having one that can turn very quickly to get into the fuse is probably still not a bad idea. Now the next thing to do is to turn these into... Is it still fair to call these flexible bus bars when they're not bus bars? I mean, I guess those aren't bus bars either. I'm going to stick with flexible bus bars. We're going to make flexible fuse bars. All right. You've all seen me crimp cables a lot, so I'll be right back. So I've got these made. Let's check if any of them deviate too far from the norm. 0.11, 0.12, 0.11, 0.11, 0.1112, 0.11, 0.12, 0.12, 0.12, 0.11, 0.12. All right, so they're all 0.11, 0.12. Sweet. That's done. So this is going to go like this, drop down like that, and bolt on to a fuse. I realized after I made these, I'm not putting a resistor directly into the 12-volt batteries. I'll have one resistor outside of the battery. And I also don't have a main disconnect switch. So I think I just made 2 of these more than I needed. I can't use these fuses in the 12-volt because the starter on the diesel is going to pull so much power, there's a very good chance that it would pop. I will still have a T-class fuse, probably have the 2 batteries come out to a common bus bar, and then, oh, how would I do this? Because almost all of the loads in the boat are going to be very, very low. The only one that's really important is going to the starter. I have to think about that some more. That is not right now's problem. Let's put the rest of these together. Okay, there's 2 done. I'm torquing this to about 3 unga-dungas. These sure are funny looking contraptions, I'll say that much. All right, the next thing I need is to get to the battery terminal. Didn't think that was going to fit. I need my socket set. Trying to recall what size that was. Was it 14? No, it's going to be big. Oh, yeah, it was 14. First try. I'm going to call that luck because my memory sure isn't that good. All right, now here's a quandary. I don't know if you can see that, but on the top it says input and bottom it says output. Which direction are they talking? In the battery, out to the load, in from the load, out to the battery. Input to battery. Got the answer. So input to battery, and yes, I know this is screwed into the negative terminal. It's obviously not a connected battery. I just need something for sizing. This is going to be really short. Let's try about there. Did I just strip this by hand with a knife? I think I did, you know. Of course, then the question becomes, where's my knife? I need to go find that. I didn't have the camera running. I kept taking a piece of this and trimming it down until I got roughly the right size, such that I can put the switch under here, and this is more or less straight down. It's really short. I've mangled the wires a fair bit, trying to get this to the right size, but I think that'll do the job. This can go in the garbage. I cut my 6 pieces of licorice. I'm going to trim these up and put terminals on them. Again, you guys have seen this countless times. There's nothing fancy to it, so I'm just going to turn off the camera so I can listen to some music. Be back in a minute. So I've got those done. I'm going to put this together on one switch and make the rest of these fusible links, and then I'm going to stop for the evening and probably stop for this video. One thing I noticed how I was doing it, and this is personal preference, but I've got the spade on the back of the fuse, so I wanted to do the same thing on the bottom one, just because I like consistency and it keeps everything centered. But that meant that this ring terminal had to be turned 180 degrees so that the flat is against the back of the switch. I'm going to get this one set up, make sure that it sits well, connect the rest of these to this. Yeah, and that'll be it for tonight. I'll torque all of these properly when I'm close to finished. For now, I'm just tightening them up. Be careful where I swing this. I don't want to blow this fuse if I bump against that. That would make me tray sad. Ha! I need to point these more inwards. And there we go. That would go out to the Anderson connector. So that's how the positive side is going to be done on the 6 batteries. Yeah, this is loose, but I'm not worried about that. This is just a demonstration. This will all be shrink tubed, of course. I may make this a little longer. I need to think about that a bit more, but for now it's fine. These will go into here in a minute, and that will be all of the parts sorted out, and I can finally begin assembly. So I'm the Digital Mermaid. This is going to be the end of the chaotic part 2. Sorry, it's a little bit over the place, but how the build's going. Next time, it's going to be getting the rest of the Anderson connections and start to finally actually assemble the battery. So hopefully part 3 will see everything come alive. See you next time.